All right, for this first video, we're going to go through all the level 6 problems before I touch on any of these levels over here. So this is the first video for the level 6. All right, so for the first problem, it's asking for you to show that you understand transformations of quadratic functions. Now, the basic quadratic function, the mother function is what I like to call it, looks like this. It's just x squared. And that one goes right there, right in the middle of the graph. Okay, and anytime you add another number to that, like if you went like this and went -4 and then squared it, or then you add a 5 to it, you're going to shift it. This one will move the graph to the left or to the right, and this number right here will move the graph up and down. There's also another number that can sometimes show up right here. We call him the a. He can be a -1, he can be a 2 or a 3 or even a fraction. And this one, the a, actually changes the shape of the function. But anyways, this first problem, level 6, is asking you just to reflect the function across the x-axis. And so the reflection would look like this. Here's the mother function. The reflection would go down. You see how it's kind of like this x-axis is the mirror, and it's reflecting over it. And what makes the function go like that, like go upside down, is a negative in front of the x squared. That is a that equals -1. And so that's all you have to write for this one right here. Now, let's go to number 2. For number 2, it's asking us to write the quadratic function in vertex form. All the forms that I wrote up here, those are vertex form. Okay, this is not vertex form. That is called standard form. So the first thing we're going to do is we're going to put parentheses around the x squared plus 6x. And you'll notice what I did that I also added a plus blank. So we have the x squared plus 6x and a plus blank inside those parentheses. Now, before I go to the next step, you also take notice, whatever I add, I also have to take away. So because I put a plus blank here, I also put a minus blank right here. And so what we add and what we take away is a 9. And the reason why it's a 9 is so that this right here, this part of the parabola, can be factored. And when you factor it, it repeats itself. It actually goes x plus 3 times x plus 3 when you factor it. Okay, and the way we know this 9 is we take the 6, divide it by 2, then square it. So 6 divided by 2, and then you square it. Well, what is 6 divided by 2? 6 divided by 2 is 3, and then when you square it, you get 9. And so that's how you know the number that you're going to add and subtract. Okay, so that's how I found the 9. And so when I factor this, it becomes x plus 3, and then squared. It's squared because we read it twice, remember, like I wrote earlier. And then we have a plus 3 minus 9, which then becomes -6. And so this is vertex form. All right, let's look at number 3. Number 3 asks us to identify the vertex, the axis of symmetry, and the y-intercept. So here is our function. The vertex is the most important point when it comes to parabolas. It's that point, okay? Sometimes it goes upside down, then it would be this point at the top. But in this case, it's right here. And so we start at the origin, and we count over 1, 2, 3, and then we go down 1. So that's why it's 3, down 1, right? 3, down 1. And then the axis of symmetry is the vertical line that goes right down the middle of the parabola. And the reason why it's called axis of symmetry is because whatever point is on one side, it's also on the other side. It like copies it. It's like another mirror. And so you have to write x equals and then 3. That axis of symmetry can also be seen in the vertex as the x number, okay? But the axis of symmetry has to be written x equals 3. That makes a line, a vertical line. Then we have the y-intercept. The y-intercept is anywhere on the on the y-axis that the function crosses. And so the function crosses the x or the y-axis right there. And so that's why I wrote 0, 8. And then the first number has to be 0 because if you go left or right, then you're no longer on the x-axis, or sorry, the y-axis. Man, I keep saying that. So right here is your y-axis or y-intercept. Forgive me. Okay, now let's look at number 4 and then 5, then we're done with this video. Okay, for graphing quadratic functions in vertex form. Okay, now this one actually is in vertex form. The thing is, though, is it's missing the h and the k. What am I talking about? Well, this is vertex form right here. And this number right here is a 0, and this number right here is a 0. which means if this was a 0 and this was a 0, you wouldn't even write those. And so that's why you just see 2x squared. So there's only an a. Now, so when I would talk to you guys about graphing quadratic functions, I would first introduce it to you guys by picking the easy x. Now, because there is nothing adding or subtracting to the x inside the squared, the easiest x to pick is 0. And when you pick 0 and you plug it in, it's very easy. You get 0 squared, and then you multiply by 2, and then you get 0. So 0, 0 goes right there. And that actually, usually the easy x will give you the vertex, the x for the vertex. Next, you got to pick a number either to the left side or to the right side. I chose to go to the right side. I picked a positive 1, and when I plug positive 1 into it, I get a 2. So I go 1, 2, and I put my point right there. Once you put a point on that side, you can copy it to the other side because you know this one's a vertex, and because of the axis of symmetry, whatever happens on one side happens on the other side. Now, just for good measure, I picked another x value. I went out one more. I picked the 2, I plugged it in, and then I got that point right there. So that's how you do the level 6 for number 4. All right, last one, number 5, domain and range. Now, the domain is the x-axis. The range is the y-axis. So domain and range, okay? And whatever numbers are on the graph, that's what your domain and range are. So for the domain, well, this one's pretty easy. Because we have a quadratic function, you can plug anything into the quadratic function. You can plug all these numbers in the quadratic function, and you'll see those points right here on the graph. You could even plug this number way over here into the quadratic function. That's because the ends of this graph go down and to the right and down and to the left. So that means this line right here will eventually make it over to x equals 10, and it will get on the graph. Now, it might be really, really far off our window that we're looking at the graph at, but that doesn't mean you can't get a 10 for the quadratic function. See, look at this quadratic function right here. Could I plug 10 into that? Yes, I could plug 10 into that, but it will be a ginormous number. 10 squared is 100, and then I multiply by 2, that'd be 200. So I would go 10, 200, which would be a really, really high point. That's like way the heck up there. But anyways, all domains for quadratic functions are going to say all real numbers. Now, I wrote it all fancy in set builder notation. I did the squiggly bracket, and it says x such that x is all real numbers, and then I close it, okay? So the first x is just saying the domain is the x, okay? So when we do the range, I say y first because the domain is the y. Now, the range is a little different because these numbers right here will never show up on this function because it goes up and stops right there. It peaks right there and then starts going down. So this number right here, which is a 1, that's my highest y value. My highest y value. All these other y values, they're below the 1. That's why we say y is less than or equal to 1 for my range. And so the way you say this is, you got to do a little squiggly bracket. The range is y such that y is less than or equal to 1, and then you close the squiggly bracket. And that's how you do domain and range.